Hello, I'd like to introduce the one-lone coder PixelGameEngine. Not long after starting this channel, I created a header file called the olcConsoleGameEngine. And this was a little utility file that allowed me to harness the Windows command prompt in such a way that we could display graphics and accept user input. And I used it to create many game demos and algorithm demos, and I think the response to this game engine has been really quite fantastic. There's quite a lot of people using it, and I think the simplicity of using it really appeals. There's very little boilerplate to do. You just include the header file and you start writing the code that matters. As my YouTube channel has evolved, the demands I've been putting on the console game engine have been growing and growing, and it has been a little bit of a competition in some way to see just what can I do next with the command prompt. The recent Code It Yourself 3D graphics engine series has highlighted some of the limitations that I'm facing with the console. Primarily, it doesn't do graphics. And instead we've had to resort to approximating graphics in interesting ways. We saw in the webcam at the console video, and subsequently some of the community's efforts to make that even better, that you can approximate graphics quite realistically, but on the whole the performance begins to really slow down. And in the texturing part of the 3D graphics engine series, we began to see performance issues due to how the Windows subsystem renders the console. There are a lot more interesting algorithms I'd like to display on this channel. But I do need some sort of higher fidelity graphics in order to do so. Yes, they will be predominantly graphical algorithms, but I'm a little bit conscious of the fact that the videos are becoming about how do we do graphics in the console rather than focusing on the algorithms underneath. And so I decided to create the one-lone coder PixelGameEngine. The PixelGameEngine, like the console game engine before it, is a single header file solution. And I've decided to create my own license to use it, olc3. It's a variation of the BSD3 license. Fundamentally it's the same, but it does insist that you give me a little bit of a nod if you use the code in something public. Now I want to get this clear straight away. I'm not going to stop using the console game engine. It's still appropriate for a lot of things that I want to do. If my applications are predominantly text-based, I'll use the console game engine. If they're predominantly graphics-based, I'll use the PixelGameEngine. And one of the things that I've tried to do, mainly due to the success of the console game engine, is emulate as much functionality of the console game engine as possible. So it's a very, very similar experience for the user. In fact, you can take most of my existing code and port it over very trivially, and we'll see some examples of that later on. One of the things I've tried to get right from the start this time, and remember when I started this YouTube channel I never really expected it to gain any kind of subscriber base at all, so compiling on other platforms wasn't a priority. However, this header file has been compiled in Linux first, and I took this approach to really try and ensure the maximum compatibility we can have with as many users and operating systems as possible. I've also tried to rely on libraries which are effectively standard with any development install, and so compiling code that uses the PixelGameEngine should be quite simple. I've also made an effort to support code blocks on Windows. Now I appreciate not everybody has access to Visual Studio on Windows, and one of the most frequent comments is how do I get your code to work on code blocks? So I guess there are parts of the world where code blocks is still quite popular. So the PixelGameEngine should compile on code blocks too. In a standard Windows environment, you no longer have to do anything at all to get the project to run. It will self-load the libraries on Visual Studio. In code blocks you need to add 4 libraries, but it's quite clearly highlighted which 4 they are, and you will have them in your default code blocks installation. I've also worked on quite a bit to get it to be character type agnostic, so it doesn't really matter whether you're using Unicode or not. Now the first major change is all of the PixelGameEngine code exists in an OLC namespace. And I've adopted this approach to allow me to add extensions later on that can exist within this namespace without contaminating the rest of your programs. Instead of characters, the fundamental unit you operate upon is the pixel, which is a 32-bit full-colour, well, pixel. And so yes, the PixelGameEngine supports transparency. In the console game engine, we had something called an OLC sprite. Well, we have an OLC sprite again. This time it's just called sprite, and it loads a PNG file. So the PixelGameEngine works with PNG files fundamentally underneath. I will walk us through a little demonstration later on, but I just want to highlight some of the features of the header file so you'll see there's a lot of familiarity with the console game engine. You first need to construct an instance of the Pixel Game Engine, and you give it a width and a height, and instead of this time giving it a font width and a height, you give it a pixel width and a height. So this means that pixels in the Pixel Game Engine don't necessarily have to have a one-to-one relationship with screen pixels, and this will allow us to have this retro blocky effect, which I quite like. But we don't have to have a retro blocky effect. In fact, we can have very high definition algorithms too. Next, we see two very familiar functions to the console game engine, onUserCreate and onUserUpdate. These function exactly the same as they did before. If you didn't know, the console game engine also has onUserDestroy, but I don't think I've used it in any videos. The nature of interacting with user input is exactly the same. We can check if the window is focused, we can get the state of a key, and we can get the state of a mouse. We can interrogate the primary display of the Pixel Game Engine exactly the same as with the console game engine with the functions screen width and screen height. There are a few more now which we may go into detail in later videos. And if you have any familiarity with the console game engine, you'll recognise a lot of these functions straight away. We can draw single pixels, draw lines, draw circle outlines, fill circles. I've now added a draw rectangle function and a fill rectangle function. We've got the draw triangle and fill triangle, which we've exploited a lot of recently, and draw sprite and draw partial sprite. So hopefully you can see that very little has changed from how the user interacts with the Pixel Game Engine. Ironically, one of the more complicated things to do now is actually draw text. But I have provided a draw string function, and we may look at the implementation of that later too. As we scroll down the olcPixelGameEngine header file, we discover a gap. Everything above this gap has been the declarations, and everything below it has been the definitions. So this means we can create the object-oriented programming alternatives to the Pixel Game Engine very trivially now. I think I'll do a separate video at some point in the future on the actual mechanics behind how the Pixel Game Engine works, but it's very similar to the console game engine. The only difference this time is it needs to create windows for the platforms that it supports. When I introduced the console game engine, I created a very quick demonstration to display noise on the screen. It's just kind of the console game engine Hello World equivalent. So I'll do the same for the Pixel Game Engine. Starting with a blank source file in a blank project, I'm going to include the Pixel Game Engine header file. Now I need to create a class that derives from the Pixel Game Engine. So I'll call the class example, which inherits publicly from olcPixelGameEngine. Now remember, the OLC is a separate namespace now. When we create a new class, it's typical to override the constructor. So I'll do just this. And as with the console game engine, you have the opportunity to name your application. Typically, there are two functions we always want to override. The first is onUserCreate. In this instance, we don't need to create any resources, so I'm just going to return true to say that this function successfully completed. The main function, where all of the guts of the game engine lies, is onUserUpdate, which takes in a floating point variable called f_elapsed_time. Again, we'll make it return true to say please don't terminate the application. With those two basic functions now declared, we'll implement the main function. So the first thing is to create an instance of our class. Now before we used to call a function called constructConsole. In exactly the same way, this time we just call a construct function. And we're going to give it the screen width, the screen height that we want, and the dimensions per pixel. In this case I'm going to choose 4 and 4. So a pixel in the Pixel Game Engine is represented by 4 screen pixels on your display. If the construction returns successfully, then we want to start the application. So hopefully you can see already that it's exactly the same as how we did things with the console game engine. Before we add any body to onUserUpdate, let's just run it and see. And so, as before with the console game engine, you can see the name of your application and a frame rate appearing in the title bar. So here we are, not needing to do any updates to the display. By default the engine is clicking over on my machine at about 5,500 frames per second. Let's make it display all of the pixels as random colours. So I'm going to go through all of the pixels in turn by using 2 for loops. Individual pixels can be drawn to using the draw function, exactly the same as the console game engine. So I'll specify the location of the pixel, and this is where things change a little bit. Previously we would have used a character and a colour. So if we wanted to display a pixel as the letter A, for example, in the console game engine, we could do that here. That's no longer an option because the pixel is now purely a graphical thing. There is no text associated with it. And so we have a variety of ways of specifying the look of a pixel. Built into the header file are loads of constant colours already, so if we wanted to display everything green, we can just use the namespace and find the constant green. But if we want to set the pixel values directly, we'll just quickly use the struct. And we can construct an instance of pixel by passing it the RG and B values. Colours in the Pixel Game Engine are represented with RGB being between 0 and 255. It's a 32-bit colour system. We'll worry about alpha later on. So I want it to pick a random number between 0 and 255. For the red pixel, I'm cut and paste for the green pixel, cut and paste for the blue pixel, and we're done. Just fix this little error up here. Let's take a look. And so there we have a screen full of noisy pixels. And it's quite pleasing because the pixels have a certain size. Now, as I said in the previous video when I was introducing the console game engine, I reckon the YouTube encryption algorithm has completely collapsed at this point. We can make things look a little bit more pixely. So let's say, for example, I choose a screen size of just 64 by 64. Very small. But I choose a pixel size of 16 by 16. Much bigger pixels. So hopefully here I've demonstrated that the way that you use the Pixel Game Engine is exactly the same as the way that you use the console game engine. You've just got to think in terms of pixel values instead of characters now. I've pulled in one of the programs I used when I first created the console game engine to demonstrate it. It was generating mazes. Let's take a quick look just to refresh our memories. As we can see, it uses a search algorithm to create a maze of any size. So I feel it's only appropriate that we try and convert this over to the Pixel Game Engine, just to see how trivial it is. So the first thing is to change over the header file to Pixel Game Engine, and we'll need to inherit from a slightly different class. Fortunately, Visual Studio will show you all the places where things don't quite add up. So this msappName variable has now simply changed to sappName. And we don't really care about it being in Unicode anymore. We'll leave all of the functioning maze code exactly the same. So it's only when we get to the drawing stuff do we need to think about things a little differently. So to clear the screen, we used to draw a filled rectangle. We now use the fillRect function for this. And this shows you how long ago this video was. We didn't even use screen width and screen height back then. So we'll change those. And since we're clearing the screen, previously we would draw a space. Instead now what we're going to do is draw a black pixel. Again, the next error exists where we're drawing something. So here we were drawing a solid white pixel. Well, by default the draw function will draw a solid white pixel, but let's just be explicit. White. And this one looks like a blue pixel. In the main function, our last remaining error is the construct console function. That doesn't exist anymore. It's just called construct. So we've really only made a handful of little cosmetic changes. Let's take a look. And you can see it performs in exactly the same way, if not a little bit faster. I'm going to do the same again, but now with the final episode of the Code It Yourself Graphics Engine series, where we looked at texturing. So I'm going to load up the Spyro the Dragon level and display it in the Pixel Game Engine. Fundamentally, the code is unchanged. The only differences are where we've been drawing and getting user input. So user input we haven't looked at yet. Instead of specifying now a particular key code native to the operating system, you specify an olc key code. but functionally it's exactly the same. Whereas we used to specify W, S, A and D as characters, we now use them as constants from the engine. All of the mechanics code of actually rendering the 3D graphics is exactly the same. Before I launch it, one quick thing, we now work with PNG graphics instead of the SPR file. So let's take a look. And here we see it's the Spyro level, exactly the same as it was before, but now looks a lot more detailed. Yes, the artifacts and glitches are still there. Please look at that video for an explanation. But we can see the performance is quite nice, about 240-ish frames per second, depending on what it's looking at. Now that we have fewer limitations on what we can do with screens, we can increase the resolution of things. So I'm going to set the Spyro to be technically high def. 1280 by 720, and in this instance I've set the pixel width and height to 1, so that matches screen pixel width and height. So even though it's called the Pixel Game Engine, in this instance it's not necessarily deliberately rendering pixels, and as you can see that looks pretty crispy. And performs quite acceptably too. In a way, I hope that this further justifies that from the graphics engine series, even though things looked a little bit rough and ready around the edges, the underlying principles were sound. And all we had was a restriction on how we rendered things. I'll just quickly show one last thing, and that is how to enable transparency per pixel, because I know some of you will want to just get stuck in straight away. So when you want transparency enabled, you can specify the pixel mode to be alpha. Don't worry, this is all documented in the header file on what this does. And then I'm going to draw a sprite at the location of the mouse coordinates. The PNG file contains alpha information already. I've chosen to specify the pixel mode separately because performing alpha blending calculations is a little more costly. Not much, but it is more. So in most cases you don't need it, but where you do need it you can enable it explicitly. Let's take a look. So here I've got, following the mouse cursor, the One Lone Coder logo, and you can see it's got some transparent elements to it. And it overlays nicely with the scenery in the background. This should make making games very simple indeed, because you can use any art package that can output PNG files to create assets for the game. The olcPixelGameEngine exists in a new repo on my GitHub, and at the moment doesn't contain very much other than the header file itself and a couple of little example programs to get you going. I'll add more as time permits. I'll try and convert over as many of my existing video programs as possible. What I will try and remind you is that there is a wiki tab on the Pixel Game Engine, and this is where I'm going to be placing more accurate documentation. Traditionally, with all new projects at the moment, they go nowhere, but I think most of you will be able to get something out of this engine without much help. Now, I don't have Linux natively on my machine, but I do have a version of Debian running in VirtualBox. And I just wanted to show that I've taken exactly the same CPP file that we've created. This is the one you've just seen in Visual Studio. And I'm going to compile it using a very simple compile string. This is also included in the header file. We might get a warning about string stream. Yeah, I'll fix that. That's actually nothing to do with the header file, that's to do with the textured demo. And let's run that. And you'll see it behaves exactly the same. The frame rate is significantly less because it's a virtual machine running on my machine, and I'm also recording all of this using OBS. But nonetheless, you can see it performs and behaves exactly the same way. And because, yes, there are some masochists out there that enjoy using code blocks, everything should be compatible with that too. So here I've loaded up the code. I do apologise for your eyes being burnt out of their sockets right now, it's just how it is. So I've compiled it and we'll run it, and it's exactly the same in code blocks too. And so there you have it, the olcPixelGameEngine header file. It's available on the GitHub, and I'm hoping that people will adopt it and start doing interesting projects with it too. I'll be using it to create some videos in the future, but I'm still going to work with the console game engine as well. I'm not abandoning it at all. Since this is a new project, there will likely be some bugs and glitches that need ironing out, so I'm hoping that the community might find some of these and let me know about them so I can do something about it. Anyway, a quick little video. If you've enjoyed it, give me a big thumbs up, have a think about subscribing, come and have a chat on the Discord, and I can't wait to see all of the Pixel Game Engine games you guys come up with. Take care.